Good morning, dear colleagues. My name is Ilnas, and I'm a student at TU Ilmenau. And today I'm going to present my project seminar, which was about development of regenerative braking control and real-time validation using hardware and tools. Presentation will consist of the main idea of project seminar, concerns, state of the art, design of regenerative braking control, which was proposed in given work, and validation software and hardware in the loop, and results. To understand how work regenerative braking, it's necessary to know that all moving bodies have kinetic energy, which can be used more useful, for example, in electric vehicles, just transfer it in electric energy. And regenerative braking control can be divided in 4 steps. First is changing the operation mode, when flow of current change the flow in motors. In opposite side, second, when vehicle velocity started to decrease, and third, transformation kinetic energy into electric, and the last one, available electric energy charge the battery. So the main idea of all projects in was to save driving perception after introduced this regenerative braking torque in some model, and that is why was established 3 ideas, concerns. Is first the ability and efficiency of electric motors to regenerate energy, the type of energy storage, and control strategies. And reviews shows that one of the main efficiency electric motor is the permanent magnet synchronous motor, which use permanent magnets on the rotor and windings on the stator. It can be efficiency of given motor can be improved also by a field-oriented control, for example. And given electric motor have to use at least 2 automatic control systems, rotor position and phase current limit, and sometimes more, for example, angular velocity. Because of limitation of electric motors, regenerative braking have to work in tandem with the friction torque. That is why we need control strategies, and almost all control strategies can be divided into groups. Is the parallel and series. Parallel means that we have a fixed ratio between the available used braking torque and friction system torque. Series. In series we use first of all available motor torque, and just after that, when it doesn't enough, calculate the difference, and this difference used by the friction braking system. Also in my project seminar was studied predictive control strategy, and this strategy have a higher efficiency than even series, because you can see that running time in series much higher than parallel. But predictive control strategy have a lot of computation and execution. That is why given strategy can be said that very complex and hard to realize. In given project seminar was used model based on Audi-Hydron, which was used battery capacity 85 kWh and 400 voltage, and almost not all in all future tests was used weighting factor 0.9 and temperature of battery 30 degrees. Here you can see the graph which describes torque speed characteristic of motors, which was used in given model, and the scheme of wheel of motors here was used in wheel motors with permanent magnet synchronous. Suggestion. Here you can see control strategy, which was used in project seminar, Here we can see the two inputs, brake pedal and wheel speed. And after that, based on lookup tables, we calculate demand torque and available originated torque. Compare them, and if it's enough available, we just use motor torque and doesn't use friction torque. But on the other side, we calculate the difference and use friction braking system. As I said previous, the main idea to save the driving perception. That is why it was made 5 experiments with 5 different pedal positions, 20, 30, 40, 50, and 60%. It was monitor wheel velocity and vehicle acceleration. And you can see this two-dimensional lookup table. We have a brake pedal input and wheel speed. For better visibility was made a 3-dimensional graph, and for the given lookup table was made other test for finding available regenerative braking control. And because of discrete points of experiments, all data in previous lookup table and here interpolated by least square interpolation, which you can see here the results. And implementation was realized in MATLAB Simulink. They did the same like in block diagram. We have 2 inputs, 2-dimensional and 1-dimensional lookup tables. Here we compare them, available and regenerative braking, demanded and regenerative braking torques, and use outputs for the torque demand and the torque for the motor torque and for friction torque. Also, you can see here the other inputs with the blending factor, which depends on the temperature of battery and state of the charge of battery, etc. And as I said previously, here was used 0.9. Software in the loop validation was realized in IPG car maker and was conducted 4 experiments with 4 different brake pedal positions. Model accelerates by 100 km/h or 27.7 meters per second. For better visibility, you can see enlarged graph with the braking 60% pedal position, and we can see that braking system response velocity has been reduced by 6 milliseconds because of electric motor start to work faster than conventional friction braking system. Also was calculate average pitch rate, and you can see that they have almost the same numbers and differ only by 4 or 5 orders by magnitude. So next was calculated braking distance, and you can see that they have in the 3 first experiments even better, we have a less brake distance, but in the last experiments almost the same, just a little higher. So here you can see the final results of all experiments previous in software in the loop, and we can see that computer simulations proved the validity of given control strategy. That is why we continue to make hardware in the loop validation, which was made in test bench. Test bench consists of in-wheel motor, which connected with a load, alternative current motor, and a lot of sensors, torque, sensors, velocity sensors, and the temperature sensors. Also, the same thing was made for experiments with the 4 different pedal positions, and also you can see enlarged graph. And here we can see that braking system response velocity has been reduced by 60 milliseconds. And I think that this time much realistic than in software in the loop, because it was made in test bench. Also, like in previous tests, you can see root mean square of pitch rate. And in all experiments, pitch rate decreased much better, you can see. And braking distance with the first experiments decreased, increased braking distance, but unfortunately, we can. But it doesn't make big sense, because with this given brake pedal positions, we don't need extra braking. And for example, with the 60% and 80% brake pedal positions, brake distance much better than in others. Also, you can see here calculated recovered energy and 4 graphs, where you can see friction torque and motor torque. For example, first of all, we started to work regenerative braking, and when it does it enough, friction braking system changed them. And you can see the recovered energy in each experiment here. And in first, for example, we have a high recovered energy, 2.35 kilowatt hour than in others. Also, was decided made a worldwide light test procedure for given model with the suggestion regenerative braking. And here you can see 2 lines, blue one and red one, but you can see blue one because it was the task, the main idea that acceleration should be the same with regeneration and without regeneration. But on the other side, pitch rate difference for root mean square with regeneration less. It's much better in given tests. But on the other side, brake distance decreased, but only by 0.25%. It's not so much, and I think it's enough. And you can see here friction and motor braking torque for the given procedure. You can see here that instead of some braking torques was changed on the motor torque, and was calculated the same recovered energy, 4.65 kilowatt hour. While without regeneration, we don't have recovered energy. So, based on the previous test, was made a table in hardware in the loop, and we can see that given regenerative strategy performed well, and the main task was decided. I mean, driver perception, and even we have a recovered energy compared with without regeneration. And conclusion. Finally, we can see that during all given procedure with the 4.5 kilometers cycle, we recovered energy, 4.65 kilowatt hour, and thanks for two-dimensional lookup table, got a similar driving experience. I mean, driving perception, and we can develop given lookup tables, and for example, increase dimensions, and it is possible to improve regenerative braking parameters. And in future, I'm planning to work further with the regenerative braking control to improve efficiency. For example, working with control in electric motors and so on. Thank you for attention. Questions?